Hello and welcome to the Great Lakes Neurotechnologies webinar series. I will be your moderator for this session. Today's webinar is Wireless Respiration Setup and Analysis. As a reminder, if you have any questions during the session, please type them in the questions box on your screen. I will compile the questions and ask them to the presenter at the end of the presentation. With that, I'd like to introduce Ms. Maureen Phillips, Biomedical Product Solutions Manager, who will be presenting today.
Hi everyone, and thank you for taking the time to join me today to talk about wireless respiration. Just to give you a quick overview, what I'm going to talk about are types of applications in which you would measure respiration, certain types of sensors that you can use in order to measure breathing and breathing rate, specific types of respiratory measurement, and then also some data acquisition and analysis. And I'm actually going to be showing you a live demonstration of wireless respiratory data acquisition using our BioRadio physiological monitor. So first I'm going to talk just a little bit in general about respiration. And typical respiratory measures include tidal volume and frequency. Frequency includes respiratory rate, and tidal volume, it's a measure that you can extract a lot of other parameters from, and so I'm going to go into detail about those shortly. There are several applications in which you might want to measure respiration, and just a few of those are sleep monitoring and trying to detect different types of sleep disorders, anxiety and stress research, cardiopulmonary research, psychophysiology. There's quite a few. Exercise physiology is another one in which monitoring respiration can be an important measure. So as I mentioned, a type of measurement that's very common in terms of respiration is volume. And currently, many people will use what's called a pneumotachograph. And it is a face-worn sensor similar to what you see in the picture on the right. And it's a mask that goes over the nose and the mouth, and that's what records inspiration, expiration. And that's what you use to record the respiratory measures, such as volume. A few other sensors that you can use for measuring respiration include nasal oral cannulas, where you can measure flow rate and also airflow using changes in pressure, thermistors, which use temperature, respiratory effort belts, spirometers. There's quite a few different types of sensors that you can actually use. So the one type of respiratory measure that I'm going to focus on today is something called respiratory inductance plethysmography, or RIP, R-I-P. And RIP is actually it's a type of respiratory effort band that's worn completely around the body at the thorax and the abdomen. And there's an elastic band, and within that band are inductive wire coils. And the way RIP technology works is a current is delivered to those coils, and as the current within those loops changes, which is caused by inspiration, expiration, and movement of the chest and the abdomen, this is what creates a pattern of breathing, and that standard sinusoidal waveform that you might normally see in a healthy subject, similar to what I have down here on the slide. What's nice about RIP is that you can measure the same types of respiratory parameters that you can with a pneumotachograph, but in a very unobtrusive way. So it's just a few bands that are worn around the center of the body, the midsection. They're very comfortable and easy to wear for longer periods of time. Another nice thing about RIP is that some of you may be familiar with a type of respiratory band called a piezoelectric respiratory effort belt. And it's similar in the way that it looks, where it's worn around the chest, but instead of having a coil that goes entirely through the elastic band, it uses a flex sensor that's located directly on the front. So in order to measure changes in respiration, that flex sensor needs to be activated. Whereas with a RIP band, because that coil does go all the way through the band, you can measure respiration through changes in expansion and contraction really from anywhere on around the body. So if somebody is laying down or even on their stomach, you'll still get a really nice accurate respiratory measurement. So what types of things can you measure with a RIP belt? So, of course, respiratory rate is a very common measurement, so looking at the number of breaths that occur per minute. Tidal volume is another common measurement, and this is just the volume that occurs with inspiration and expiration. Minute ventilation is tidal volume multiplied by respiratory rate, and this is a very common measurement used in metabolic applications, including exercise physiology and sports testing. Peak inspiratory flow is a measure that reflects respiratory drive, and respiratory drive is actually the urge to breathe. So looking at that, and when the value of peak inspiratory flow increases, the respiratory drive increases. Fractional inspiratory time is the ratio of inspiration to total breath time, and there's several other parameters outside of even what I have mentioned here: work of breathing, peak and mean inspiratory expiratory flow, phase angle. All of these are appropriate for several different applications, and if you have questions specifically about them or how they're used, feel free to ask those at the end of the presentation. I'd be happy to go in some more detail about those for you. So this is a setup of what RIP would look like. So you can see that there's bands worn around the chest here and here, and there's sometimes a question as to whether or not you might want to use just one band around the thorax, or if you want to use two bands around the thorax and the abdomen. And if you look at the physiology behind respiration, it really involves movement of the abdomen and the thorax, not just one or the other. So having both bands is really needed in terms of, or in order to get accurate respiratory measurements. And that includes the measurements of volume, flow, rate, and anything that's derived from those. If you did use just a single band, you'd be able to calculate respiratory rate just looking at the waveform of the inhalation and exhalation, but you cannot accurately record respiratory volumes. So that's why using two bands is actually really important to make sure you're able to derive all the parameters you need for your specific application. So as I mentioned, I'm actually going to give you a demonstration now of wireless respiratory measurement using RIP. So I'm going to switch over to our data acquisition software, and then I'm going to open up the webcam. Hi everybody. First I'm going to talk to you about our BioRadio data acquisition device. This is what I'm going to be using to record the respiration data. And this is the device here. It's a wireless 8-channel physiological monitor, and there's inputs along the front here on which you can measure really any type of physiological signal. So for today we'll be demonstrating RIP, but you can also record things like ECG, EMG, you can look at blood oxygen saturation, several different parameters. So it's a nice flexible device to use for a number of different applications where you may not only need to record just one type of signal. This transmits data wirelessly over a Bluetooth radio linked to a receiver. It's about this big, and it plugs into the USB port on the computer. So in addition to using RIP, which is a nice uninvasive measure of respiration, combining that with the BioRadio, which is a wireless data acquisition device, are really opening up the opportunity for recording data in a number of different environments. And this really frees up the subjects to move around and give them a more natural environment in which you can collect the data. So the next is the RIP belt itself. So this is what a RIP belt looks like. It's elastic, as I mentioned, goes completely around the chest and the abdomen. And if I hold this closer, you might even be able to see that coil that's going through the center of the belt there in a sinusoidal form. So as the belt expands and contracts, that's what's causing the current that's being applied to be transformed into the respiratory waveform that you're going to see on the screen. So in order to capture RIP, first we want to set up the BioRadio and the BioRadio data acquisition software in order to collect the data. So the first thing that I'll do is open up this window here in order to program the device to be appropriate for recording respiration. Okay, once you've selected your parameters, as I mentioned, you can record other signals as well, and you would set those up just by clicking these boxes here and then choosing the appropriate input range for that signal. I will click Program Device, and now we're ready to start collecting data. So to connect the RIP band to the BioRadio, there's actually a snap electrode interface on the belt itself. So we have an interface cable that looks just like this, where the snap electrode leads are on one end, and that connects to the belt. And then there are no touch connectors on the other end, and this is what actually plugs into the inputs on the BioRadio. So I will plug those in and then just click Start within the BioCapture software. So now you can see that as I expand and contract the belt, you're getting the response in the data on the screen that correlates to the respiration, the inhalation and the exhalation. What's nice with the RIP, again, because of that inductive coil that's being used, is that it can even pick up very sensitive movements. So even if you just have the slightest tug on the belt, you're still going to see respiration that's occurring, as well as if somebody is taking normal, larger breaths, you'll see the larger amplitude signal. And so the amplitude of the signal does correlate with the strength of the breath, I guess you could say, that's being taken. So the smaller expansions of the belt result in a smaller amplitude waveform, or larger show the higher amplitude waveform. So the BioCapture software is really pretty simple, but it's nice because with the BioRadio, you can get up and running very quickly in terms of collecting your respiratory data. Within BioCapture, you would save your data files, and then we have a few different options that you can use in order to analyze your data. So that's what I'm going to show you right now. So I'm going to stop this, and then I'm going to click over to what we call the VivoSense Analysis Software Package. What you would do here is import data files that you saved with the BioRadio, and you can do very nice, easy, automated analysis with the data that you've collected. So right here are 2 channels of RIP that we've collected, one for the abdomen, which is the AB you see over here, and one for rib cage or thoracic. So this is just the raw data that was collected. But you have the option of applying a number of different algorithms to this automatically in order to calculate different respiratory parameters. So the first thing is you can calculate respiratory rate. So just by clicking on this box here, you can actually go through and select the different measures that you want to automatically calculate. So you can look at respiratory phase, you can look at different timing measurements, and so this is where I'll select respiratory rate. By double-clicking on that, it brings up a plot that shows you the rate of respiration. And the plot is dynamic, so as you scroll through the data, it will automatically change according to what is being collected at that period of time. You can also change the window size to look at larger or smaller segments of data. So in addition to just looking at the raw data and respiratory rate, you can also quickly look at volume. So clicking on volume here, I can double click on expiration and inspiration here to look at the volumes of both of those. There we go. And again, it's dynamic, so as you scroll through, you can look at the volume occurring over these different time phases. And while you're looking at this in a graphical format, you can also export all of this data. So instead of just seeing here, at what point right here was the respiration rate, you can export all of this to get the numerical value in addition to the raw data. So there's several more advanced analysis techniques that you can do with VivoSense, and it shows all of the different parameters that you can extract from the respiratory inductance plethysmography data that you've collected. So the first thing I'll show you is something that's called a Kono-Mead loop. And when I double click on that option here, the first thing that you see, or I'm sorry, I guess the second thing that you see is the abdominal and thoracic respiratory effort that's occurring here. And then this is a chart of the flow volume. And you can see that as I mouse over, or I guess hover the cursor over different points here, the 2 charts above are dynamic and they change with the movement. So a Kono-Mead plot, which is what you're looking at here and here, these show the thoracic against the abdominal signal that was recorded. So you can see the thoracic signal is here, the abdominal signal is here, and it's plotting them against each other. And what a Conomed plot is used for is the analysis of asynchrony between abdominal and thoracic breathing. And then other terms, this is called paradoxical breathing. And this is basically the opposite of what you might see in normal respiration. So if somebody's abdominal and thoracic respiration become out of sync, if you don't see them occurring together as they do right here, that's what's called asynchrony or paradoxical respiration. And if that does occur, you would see this Conomed loop start to shift counterclockwise in a 45-degree angle. And the reason somebody might want to measure this and look at this type of analysis is because a Conomed plot actually can indicate different types of pulmonary distress, a respiratory blockage. It's also a way of measuring respiratory muscle dysfunction. And so when you're looking at these plots, if there is asynchrony between the two respiratory channels and you're trying some type of therapy, you could use this plot to measure whether or not that therapy is actually working to get the abdominal and thoracic respiration back into sync. A second option is what's called a flow volume loop. And again, what we're seeing here is the raw data, or excuse me, this is the processed flow data. So this is volume and flow of the respiration. And the flow volume loops are plotted here. And this is actually the relationship between lung volume and air flow. So the inspiration and expiration flow is displayed on the y-axis, and the volume is displayed on the x-axis. And the plots here, the data that it displayed can be used to study obstructive or restrictive lung diseases. It can be used to, again, just like the Conomed plots, track whether or not different types of respiratory therapies are working for certain patients. So this data, again, is all dynamic. As you scroll through and you mouse over different areas, you'll see the dynamic changes in the flow volume loops. It's same for the Conomed. And just like with the other measures that I displayed, you can export all of this data to have it in numerical value. So even if you do your own analysis, let's say in MATLAB or some other type of package, this is kind of doing the front end for you, which is really nice. So you'd get the volume, you get the flow values, and then when you export that, you can go into more details that might be very specific to your study or to your particular application. So let me jump back then to the PowerPoint so I can show you. Let's see here. All right. So let me just get back. I have a couple pictures here of the data analysis that I actually just showed you, so we don't need to go into details about that. But the next option that we have for data analysis is what we call the software development kit. So I mentioned that if you do your own analysis in MATLAB, you can export data either from the BioCapture data acquisition software or from the VivoSense analysis software to import those data files into MATLAB and create your own respiratory plots if that was of interest to you. The second option that you have is to even bypass the data acquisition software that we provide and use our software development kit to create a real-time custom application. So you can have data from the BioRadio streaming directly into LabVIEW or MATLAB, or maybe you already have an existing program that you use. You can use the software development kit in order to do that. So one other thing I'd like to mention is an actual application in which the BioRadio and RIP belts are being used. And this is a really interesting study that originated out of the University of Rochester. That's the main center, with a number of other sites throughout the United States. And this is an ongoing study called the PrEP study. That stands for Prematurity and Respiratory Outcomes Program. And the goal of this study really is to identify different types of biomarkers, such as biochemical, physiological, or genetic biomarkers, as well as other clinical variables to potentially predict pulmonary status in preterm infants. So an issue with preterm infants or neonates is, since their lungs are not fully developed or fully evolved, pulmonary disease can be a common cause of morbidity. So what this study is trying to do is look at different biomarkers to detect states of development of lungs of premature babies to see what can be done along the way to make sure that their, whether it's therapies or different types of treatments that are being administered, are working and really provide the best type of outcome for the patient itself or the baby itself. So some of you may or may not be familiar with RIP technology. The one thing that I do want to mention is that it has been extensively validated with, no exaggeration. There are thousands of studies that have been done using RIP belts, similar to the study I just mentioned with the neonatals, up to sleep disorder monitoring, exercise monitoring. And these are just two examples from studies that I found where the conclusion was RIP really is an accurate and reliable method for monitoring of patients in an unobtrusive way. Both of these relate to exercise physiology type applications, but there are many publications that have been done, or studies that have been done, really just to validate RIP technology itself, and then also using RIP in specific applications. So it's a very widely used method for collecting data and for respiratory data acquisition. So here's some references from my talk, and just to kind of bring everything back together, respiratory inductance plethysmography is a great method to measure respiration and derive several respiratory parameters like volume, flow, and respiratory rate in an unobtrusive and easy to use way instead of using that pneumotachograph, which again may be perfect for certain applications, but if you have somebody who needs to move around or needs to be in a more natural environment, RIP belts are a really nice solution for that. So if you combine that with wireless data acquisition, you're giving yourself a lot of flexibility and opportunity to open up your study into areas that you may not have been able to do before if you're talking about larger systems or something that's kind of tethered or maybe even uncomfortable for the subject to be wearing. So with that, I would like to open up the floor to some questions. I'll turn on the webcam so you can see me again. So if there's any questions, I'd be happy to answer them.
As a reminder, if you have any questions, please type them into the question box. We do have a few here. First, is there a synchronous analysis with different signal receptors plugged into the BioRadio, for instance, the RIP bands and a thermistor?
If you're asking, how does RIP compare with other types of respiratory measures, yes. We've done that same type of research in just in-house where we've compared RIP with a thermistor or even a nasal oral airflow couple. There's also several studies that are available which I could provide to you that actually correlate the output of a RIP belt to that pneumotachograph so that it shows a really nice correlation between the output of the pneumotachograph and the respiratory effort belt. So it's really validating it against other very commonly used respiratory measures.
Okay, do we need the knowledge of physiology to use the device and software?
That's kind of a yes and no question. So you would definitely want to know what you are recording. You want to know the details of your study and what kind of outcome measures you're looking for. The really nice thing about the BioRadio, though, is, as you probably saw, it's very easy to get up and running and collecting your data. So all you need to do is plug in your sensors, click start on the software, and get going. So there's really not much technical preparation that goes into the use of the device. However, you would need to know, as I mentioned before, the intent of your study, your outcome measures, what exactly it is you're looking for. But we just provide a nice interface where you can get up and running easily, and then also with the VivoSense analysis software, it gives you the opportunity to analyze your data in some really specific ways without having to have tons of technical knowledge behind that.
Okay, another question. Does the software have a threshold or markers to indicate abnormal conditions?
There's nothing there right now where where the software can automatically detect an abnormality. However, within the VivoSense software, you can scroll through and you can manually look for any type of abnormality, and then there's an annotation function where you can make different marks throughout the data that you've collected. If you saw something that maybe looked a little bit unusual, let's say you were looking to detect an apnea or a hypopnea, you can make those marks throughout the data that you've collected. Now that's just with the standard software that I showed you. However, there are customization options available, so if you were looking for that type of analysis function with automated detection, we could definitely talk about integrating something like that for you.
Okay, is there, if you could talk, I guess, a little bit about the significance of respiration measures in general medicine?
Well, I guess it really can span across a number of different areas. So maybe general medicine can mean a lot of different things, but respiration is really important for detecting different types of pulmonary diseases. So if there's an issue with an obstruction of the lung, if there's something wrong with the way that the lungs are inflating or deflating, if there's something out of sync with the abdominal versus thoracic expansion and contraction, all of those things can be indicators of some type of lung or respiratory problem. And RIP is a medically validated technology that is used commonly for diagnosis of different diseases and different respiratory disorders. It's used additionally in things like sports medicine training and looking to optimize athletic performance. So, you know, it goes across a lot of applications in terms of general medicine, in terms of research, in a lot of different environments.
Is it possible to plug a peripheral oxygen measurement sensor into the BioRadio, and has that been developed or tested?
You can integrate custom sensors with the BioRadio. As I mentioned, the 8 channels, let me grab the device here real quick. The 8 channels here on the device are programmable within the software, so you can set the coupling type, the gain, the sampling rate, resolution, all of those parameters to be appropriate for different signals. So many of our customers will integrate custom transducers with the device, and really all you need to make sure is that the correct connector is on the end, and that the output of that sensor is within the input range of the BioRadio, which is plus or minus 2 volts. I can't think off the top of my head of a specific instance and where that's actually been integrated, but I could look into that for you a little bit more to see if we do have any customers doing that. The other thing I'll mention, like I said about software customization, is we can do hardware customization as well. So if you're interested in integrating that type of sensor, we can work with you to create the interface between the sensor and the BioRadio to make sure you're getting the appropriate data output.
Okay, it looks like those are all the questions we have time for.
So thank you everybody for joining me, taking the time. I hope that this was informative for you. I want to let you know that I'll be following up tomorrow where I'll provide the slides from the presentation, and you'll also be able to view an actual video of this. So if you wanted to review some of the information, if you maybe have colleagues who didn't have a chance to join, that'll be available for you to take a look at on our website. So that should be coming in an email for you tomorrow. So thank you again for your time. I hope you all have a really nice day.